one important point regarding enzyme in general is that it's a natural occurring protein. So enzymes are present in every living organism, and they are produced by a living organism. It's completely natural. It's already present in grapes. So it is a very good approach to many challenges in winemaking, particularly when we want to be natural and not go against what happened by itself in the winemaking. So it's a family of protein that is produced by living organism, really to assist and make reactions happen. So it never participates to the reaction. It's never a substrate or just a product of the reaction, but the enzyme itself facilitates a lot of reactions and speeds up a lot of reactions. Each enzyme is very particular with a very specific structure that gives it a specific activity. So depending what you want to do, you really have to choose which enzyme you will use. This is valid for everything. So enzyme that we have in our body will not be the same than what you have in a plant. It's very different applications, so different structure and different activity. In winemaking, the big family of enzymes we use are pectolytic enzymes. They all are having some kind of pectolytic activities. So they will all be here to break down some part of the pectin, but they also have side activities that are very interesting. So most commonly, enzymes are used for clarification and helping filtration. So we're going to talk about this. Enzyme can be used for extraction by losing down the cell walls of the cells of the skin of a berry, not destroying them, but losing the cell walls. You will improve the extraction after a physical force, so like a pressing or punch down, for example. You're just going to improve the extraction of all the compounds that are present in the skins and the cell of the berries. Aromatic expression, enzyme can be used to reveal some aromas, so they can be used to be to break the link between an aroma and a sugar that is usually making an aromatic precursor. So when aromatic compounds are in precursor form, they are not volatile, they don't express themselves, at least for us. But if you release them from their sugar or from their precursor, they become volatile. So enzymes can do this. That's what happens in a yeast, usually. It's an enzymatic reaction within the yeast, but we can have this enzyme also available to add. And the last point that enzyme can be used for are actually to improve mouthfeel, to give some roundness, volume, and body to the wine. So using enzyme in winemaking, in addition to be a very natural approach, there is also a lot of advantages, such as qualitative, because we can have just a better extraction with a better rounder mouthfeel. We can have more aromatic expression. But it's also very practical. We can save a lot of time by improving the clarification and improving the speed of the extraction of the compounds. And economic, as using an enzyme by improving filtration, improving clarification, improving lees compaction, improving filtration. This will increase your yield. You will lose less volume in the lees because you will have less lees. But also when you favor extraction with enzyme, you can really increase your yield of free run at the pressing when we're talking about whites and rosé, but also of free run wine when we're talking about red wine. So we're going to talk about all this, but it is there is a big economical advantage too. Very important point when we talk about enzymes in winemaking is to talk about the purification. This is something that not everybody does, and I want to talk about it because it is essential to use purified enzyme to really avoid unwanted side activities. Okay, so we're going to talk about all of this today. Starting with why is it important to purify or to have a purification process when we produce enzymes. So all our enzymes that we have at La Motabier that are distributed by Booker Vasson North America are purified of cinnamylesterase activity. Cinnamylesterase activity is an activity that is very present in most of the enzymes on the market unless they are purified of it. And it is an activity that will actually produce some acid phenols that are precursors of vinylphenol and ethylphenol for Brettanomyces. So basically what happened in the juice, we always have like ester tartrates, they are phenols that are present here, present in the grape, present in the juice. These phenols, as they usually get oxidized and lost, or they can be transformed by the cinnamylesterase activity into acid phenol. This acid phenol that you can see here can then be transformed into a vinylphenol by some yeasts, the yeasts that are POF positive. So POF positive is a yeast that has a gene able to transform acid phenol in vinylphenol. Many yeasts are like this. If your supplier doesn't tell you that the yeast is POF negative, usually it means that the yeast is POF positive. All our yeast are POF negative, so they don't have this ability. And Brettanomyces has this ability to do this too. And then the last step is usually only Brettanomyces who transform vinylphenol in ethylphenol. But if you understand well the reaction, if you don't have the acid phenol to start with, Brettanomyces will have more difficulties to produce ethylphenol. So by making sure you have enzymes that are purified of cinnamylesterase, you really help having less aromatic precursor for bread to produce bread taint. This is also why bread presence and bread taint depends a lot on varietals, because not every varietals have the same amount of tartrate esters. So this can also make a big difference. Just to give you an example, here we are looking at the control in gray, in blue, an enzyme from a competitor, and then in red, we have an enzyme crush in red purple. And you can see that after we use this enzyme, basically the concentration of caffeic acid and caphtoric acid, so we are here in the acid phenols, are way higher when we use enzyme X. So this enzyme was not purified, and so we increase the amount of acid phenols, precursors of bread taint. Okay, so very important to use enzyme in winemaking that are purified. Ask your supplier if they are. So you make sure you don't give bread more aromatic precursors. So now let's talk about the different applications. So we'll start with clarification and filtration. Why are we talking about this? Well, clarification is important to improve fermentation capacities, to prevent reduction, to reduce the amount of oxidases present in the juice, so control a little bit better the oxidation, reduce herbaceous compounds too. So clarification is commonly done in whites and rosé. When you use enzymes and fining agent, it's very common that it is overnight, 12 hours. Some people use way longer time to clarify. But as you understand, if you take too long, first you use a lot of energy, you block a tank, but also you take the risk to have a fermentation with high solids, which will higher the risk of fermentation and have more reduction, have more oxidation, and have more of aromas. So we do want to do a clarification usually on whites and rosé. How do we do this? Well, with enzymes, we can reduce the viscosity very quickly. That's the goal. So to reduce it quickly, we need to focus on three pectin activity, or three pectolytic activity, sorry, that will break down the pectin chain. So there is a pectin lyase. This one is very good for enzymes that will act very quickly, reduce the viscosity very fast, and also, so we want to use this, an enzyme rich in pectin lyase for quick clarification and flotation. Pectin lyase cut randomly the chain of pectin that you see here. That's a big chain of pectin. The pectin laser is going to cut randomly, making pieces of pectin not too small, but small enough to float or to settle, but it's very quick. Then we have the pectin metylesterase and the pectin polygalacturonase that are two activities that work together that are very important too. Pectin metylesterase will come and cut the methyl group from the pectin chain, which then allows the polygalacturonase to come and cut between each little basically piece of sugar. So these two enzymatic activity work together. They are way slower and they are way more efficient to make very small pieces. So this is very good to have if you want very strong clarifying enzyme, not necessarily for flotation, but for settling. But you always need a kind of the three activities to really make sense and have a quick answer. So when you want to improve also the compaction and the clarification, you can always use fining agents. Just be careful when you use bentonite that removes protein, because enzymes are proteins, so you will remove them as well. So you do want to use your enzyme first, maybe half an hour in between, and you will then can put your bentonite. Most commonly, these enzymes are added at the press pan. So not on the press, not on fruit. This is very important. If you use a clarification enzyme on fruit, it's going to break down way too much the cell walls. And so you take the risk to have your grapes that are becoming very mushy, and your must very hard to press, and your must very turbid. And also on red wine, it becomes just way too liquid and pasty. So definitely not clarification on grapes, but you want to use clarification at the press pan. To make sure your enzyme actually worked, if you are in a high pectin situation, you can do a pectin test, as you can see here. So you would use 1 part of juice and 2 parts of alcohol with 1% of HCl. And basically, if your juice is clear, you are completely fine. There is no pectin. But if you start to see a lot of flocules like this and a lot of haze, that means you still have pectin. So, or you need to use more enzyme, or you need to wait longer. Okay. So our solution at La Motabier is an enzyme clear. We have one enzyme for clarification that is a liquid enzyme. It's a mix of different pectolytic activities. It is purified of cinnamol esterase, and it's also a non-GMO enzyme coming from Aspergillus niger. It has a lot of pectin lyase activity. So it's a pretty strong and quick depectinization that is perfect to use for clarification, but also flotation. This enzyme is very resistant to low temperature, so you can also use it all the way to 5 Celsius. And it will resist also to wine, so you can as well use it for improving your filtration post-fermentation if you need to. Dosage is usually 2 to 4 milliliter per hectoliter. Just to show you an example here, when we have a control without enzyme, that's the yellow line. We're at 6 degrees Celsius here. You see that in 8 hours, the turbidity didn't decrease much. We started at like 650 and we are at just below 500. With our competitor enzyme here, we are in 8 hours, we are reducing below 100. But with our enzyme, we can be below 100 in 4 hours. So this means 2 things. It can allow you to go faster, or it can allow you to use half dosage. Okay? Because enzymes are always working like this. The activity of the enzyme depends on temperature, time of contact, and dosage. So if you want to change one of the 3 parameters, you will have to increase one of the other. Now, if you want to improve your filtration, so let's say you did your wine and then you still struggle to clarify your wine, and then you want just when you filter or when you're gonna cross flow your wine, you want to make sure you have a good rate, you can go fast and you don't lose too much. You can use enzymes for this. It will help really all your the flow of your filter. and you're gonna get a way better yield, which means advantage, economical advantage, but also practical advantage. So for this reason, to really help cross flow and filtration and have a better yield at these steps, we developed the EnoFlow Max. EnoFlow Max is has a lot of side activities. It's a pectinase very rich in many activities, so it's actually highly active everywhere on the pectin chain. So it has a arabinogalacturonase activity. So you see here the pectin chain. It basically is able to cut arabinane. It's able to cut the arabinogalacturonane. It's also cutting, of course, the pectin chain with the pectin metylesterase, the polygalacturonane, and the pectin lyase. There is also some hemicellulase and beta-glucanase. That's the glucan is another polysaccharide that is very present when there is some botrytis, but it can also be present just with bacteria contamination or just naturally depending the vintage and the weather. We realize that last vintage has been very hard to clarify and filter, not because botrytis, but because presence of glucans. So EnoFlow Max can really help in this case when you do have some issues with clarifying and filtration. Okay, this is a result of a trial where we look at the Vmax. So the Vmax is really showing you the speed and the filtrability of your wine. Basically, the higher it is and the better, the more filtrable your wine is. And you can see that we more than double the filtrability index, basically, of we more than double the Vmax using EnoFlow Max compared to a control here. So very interesting enzyme to help clarification and filtration. The second step I want to talk about is extraction. So this is going to be a big step for the use of enzyme. So let's go a little bit on some explanation of how is the berry cell walls and the pectin structure. So you can see here a cut of a berry. Yeah, and this is the pectin structure where the cell wall structure, where we have cellulose, hemicellulose, and then a full pectin matrix that makes everything very hard and very tight. Okay, this is normal. It's making the berry just resistant to everything and as a whole. When we look at the cells that are inside the berry, we see that they have very thin cell walls and mostly linear pectin chains. So not very complex, pretty easy to break down, not as strong and solid. Then when we go on the skin, you know, and closer to the skin, we realize that there is a lot of very thick cell walls with complex pectin matrix, a lot of branches, and it has a lot of cellulose, hemicellulose as a skeleton. So these are very hard to break. And so we make the extraction of all the compounds from inside to outside harder. It's not very hard to extract from the pulp, but it is very hard to extract from the skin. The idea here is to use an enzyme, an extraction enzyme, not a clarification enzyme. Use an extraction enzyme to start to cut a little bit this pectin matrix, a little bit everywhere. So not only the linear pectin chain, but a little bit everywhere. This way, you're going to start to lose down the cell walls, lose down this full matrix, and help the extraction of compounds after you use some physical pressure. So it can be just contact time with just the weight of the berry themselves. It can be a press. It can be punch down. It can be pump overs. Anything that applies some pressure will help releasing the compounds inside. If you use an enzyme for extraction, you really improve this speed. So using an extraction enzyme such as an enzyme crush, which is a liquid pectolytic enzyme, again non-GMO and purified of cinnamylesterase and anthocyanase activity, will help you to increase your free-run juice and your free-run wine yield. This is because by just losing down everything, when you press, you get just way more yield. by increasing your free run, you allow yourself to increase to have more qualitative juice. So you can have two options here, or you just keep the same yield than usual, but you have more qualitative juice or wine, or you just increase in total your yield, so you have more wine by just using enzymes. So that's economical and very practical advantage. You will have more aromatic compounds because you extract aromatic compounds from the cell of the berries, more polysaccharides. Your polysaccharides are very important here. Some polysaccharides, you want to cut them, they have the pectins, but we want to cut and to reduce viscosity. But there is many polysaccharides that are very interesting for mouthfeel, but also for stability. So we do want to extract this one. And by using an enzyme, we realize that we extract 50 to 60% more polysaccharide. And so we have wine that are more stable and with way more interesting mouthfeel. We extract more phenolic compound and color, and we improve, because it is a pectinase, we improve clarification and filtration. Usually, this enzyme is not enough to completely settle, overnight a juice. So you would want to use also an enzyme clear. But if a juice is not hard to settle, it could be enough. So you would use an enzyme crush on grapes. You need at least half an hour of contact. So there is different options here. Or you use it when you pick, or you use, and so it's just in contact during the transport and the transfer of the grapes to your winery, or you add it on the top of the beans while you receive the beans, and so it has some contact while you process, or you add it by layer when you fill the press, and so the time you fill the press, it can be half an hour, you will have enough contact time. Just to give you an example that not every extraction enzymes are the same. So here there is it's a picture of the Schiff test, which is a coloration of the polysaccharide that are present in the cell wall. So everything that is pink is basically the polysaccharide that are in the cell walls. So you can see that the control has very thick cell walls. There is no enzyme here. We didn't really lose them or break this polysaccharide. We use this is a competitor enzyme that we use at 30 mils per ton. And as you can see, it broke very well the cell walls of the inside of the berry, so the pulp, but all the outside of the berries, all these cell walls that actually, you can see all the pockets as well of anthocyanins of color here are not broken. So we are here making a wine, making a juice very mushy, very juicy, but with no extraction of compounds from the cells. When we use our enzyme, you can see that there is a little bit of red everywhere, but also a little bit of white everywhere. So we really broke down a lot of polysaccharide everywhere, but not everything. So we still have full structure of the cells. So the berry is still intact, it's not mushy, it's not crushed, it's not broken. It's just loose and soft, so the extraction is facilitated. Okay, we have hydrolysis of every cells, basically, instead of having some selective hydrolysis that is not what we are looking for. That was a big part of our job here, to select an enzyme crush. So now, results of using an enzyme crush. Here in Chardonnay, where we are looking at keeping the same yield in total. And you can see we just separated by color the free run, the first press, and the hard press. When we use an enzyme crush, we can increase from 45 to 58% of the juice is becoming free run. So we have, I would say, more than 10% increase of free run here by using the enzyme crush when we fill the press. So it's a very good tool to increase your qualitative juice. Another trial here that this has been done in Provence for rosé, where basically we look at different approach by using an enzyme. You have your standard press, or you want the same yield, but you want to press less strong and also save time. So your press, instead of being 80 minutes, become 30 minutes for the same yield, and you end up with only qualitative juice. That's when we use enzyme. The other option here is you keep the same press cycle of 80 minutes, but you increased of 10% the final juice volume. Okay, so using an enzyme crush will allow you to have more free run juice, so more qualitative juice, but also more juice in total. Then we also allow a better extraction of enzymes. So you can see it here of aromatic compounds. You can see it here. We look at thiolic compounds that's in the final wine, the control, or the wine made with enzymes, the enzyme crush, and we double, more than double the aromatic index here on this trial. And if we look at red wine, we are able to extract more color and more tannins, so having a color that will be more stable later on. So you can see here the rate of extraction of the compounds in red wines. Usually we extract better the anthocyanin early on because they are water soluble and they are very easy to extract, small molecule. The skin tannins though are harder and they come later when there is more alcohol. The idea of using an enzyme is to really shift this skin tannin extraction a little bit closer to the anthocyanin, so we have tannin to stabilize our anthocyanins. By using an enzyme such as an enzyme crush, you will have a better extraction of the tannins, which is IPT here, the little yellow dot, where we ended up in the wine with more tannins, and we also ended up with a more red color, as you can see on the last line here. We have more color in total, but mostly the difference is on the red side. While again, this was compared to an enzyme, competitor enzyme that didn't do much on the color and on the phenolic compound compared to a control. So not every enzyme are the same. Be careful how you select them, and also how about the purification for sure. But then you can do trials to compare enzymes because they are not gonna give you the same results. An enzyme crush is a very good enzyme to improve the extraction without making your grapes mushy. Okay, so better yield extraction, better more aromatic precursor, more phenolic compounds, more color and more stable color at the end, but also more polysaccharide extraction. Polysaccharide from the grapes that we are seeing more extracted with an enzyme crush are the it's in the polysaccharide rich in arabinose and galactose. In this family, we are actually looking at the arabinogalactan protein. So this is the type 2. So this is the one we are interested about because they are really good in terms of mouthfeel and giving you a lot of stability. And then we are looking at the raminogalacturonide type 2. These are in the cells mostly, and the AGPs are in the skin. There is many studies that shows that all these polysaccharides are acting as a protein colloids, so they prevent protein haze. They can inhibit tartrate crystallization, so your wines will be closer to stability. But they also participate a lot to mouthfeel and wine balance. They reduce the tannin aggregation, they reduce the astringency, and they give you this viscosity, volume, weight perception, and they reduce the heat perception of the alcohol too. In sparkling, they increase foam stability in sparkling wine. There is a full webinar dedicated to polysaccharide that I highly recommend you to watch. Today, I just want to focus on the fact that using an enzyme such as an enzyme crush will allow you to extract about 50% more polysaccharide than you would do without the enzyme, which is very interesting for the quality of the wine. So now we talked about extraction. There is a lot of positive and advantages about using an extraction enzyme. Now, another family of enzyme is about aromatic expression. So focusing on aromatic expression, there is two big families of aromatic precursors that we find in grapes. They are the noresoprenoids and terpenes that when they are in precursor form, there is an activity like a beta-glucosidase activity, which is an enzymatic activity that a yeast can have that will help to release the aromatic precursor into an aroma. Okay, and these noresoprenoid terpenes, they smell very floral usually. They are like violet, roses, cherry, spices, a lot of red fruits, berries, spices, and floral notes. The other family of aromatic compounds that are present naturally in the grapes and needs to be expressed because they are in precursor form are the thiolic compounds. And these are usually released by the yeast with an activity that is called a carbon-sulfur beta lyase. Okay, so these two enzymatic activity, yeast has it inside them. Some yeast better than some others, so that's why we recommend yeast for expression of terpenes, noresoprenoid, and some yeast for thiols. But it's never too late. So even if you don't use the proper yeast, you can still use enzyme later on to help expressing these aromas. If you don't use, even if you use the proper yeast, in reality, a yeast maximum, the best yeast for expressing these aromatic compounds will express maybe 70% of it. So you still have a good 30% of aromatic compounds that you can express later during aging. And in this case, we would recommend to use an enzyme FW. An enzyme FW is a pectinase with a beta-glucosidase activity. It will help you to express your terpene and noresoprenoid aromatic precursors. So it's going to increase your aromatic intensity overall, the floral and fruity character. Very commonly used on Riesling, Viognier, Gewürztraminer, but also on red wine such as Pinot Noir, Syrah. It will give you a lot of aromas that are not necessarily expressed post-fermentation. So the application is you're going to put this enzyme, this is powder, you're going to put it during your aging, pre-bottling. It needs about a month of contact, 4 to 6 milligrams per hectoliter, and ask us because we can give you samples. So you can try in your bottle and then you can decide to add it in your wine. You do a 2 weeks of contact in the bottle. If you increase the dosage and you put it in your lab temperature, it will give you a good result. And then you can adjust the dosage depending the time and the temperature you have. The second enzyme is an enzyme thiol. This is a liquid pectinase with beta lyase and beta-glucosidase activity, mostly beta lyase though. So this enzyme is able to express some thiolic precursors and also terpenes, noresoprenoid. This is a very unique enzyme. There is no enzyme on the market that have this beta lyase activity, not that I know of. So it will really make a big difference into your thiolic compound expression. Very interesting to use during fermentation or during aging or pre-bottling. 4 to 6 milliliters per hectoliters. We have samples, so same thing, you can try in a bottle. If you like the result, you can just add it into your wine. When we talk about thiol, we think mostly about white and rosé, but in reality, we have been doing trials with an enzyme thiol on red wine because red wine are actually full of thiolic compound too. And we got very, very interesting results. So I want to show you some results here. When we use an enzyme thiol on rosé, we increase the freshness, the red berries, the tropical fruit, but the overall quality and length of the aromas. When you use it on white wines, we are increasing the freshness, the citrus notes, the length of the aromas, and also the overall quality of the aromas. When we use it on red wine, and red wine full of thiols, they can be Pinot Noir, Cabernet, Malbec, Merlot, Grenache, Syrah, there is Mourvèdre, there is a lot of varietals that are very rich in thiolic compounds. What we saw when we use an enzyme thiol on red wine is a switch of between fresh and ripe fruits. So we really refresh the nose. So we increase the perception of fresh fruit, and we increase the perception of cleanliness and purity of the nose, and we decrease the perception of ripe fruit. So very good tool to help refreshing the wine, if you have some overripe character in your wine, or if it's a hot year, you can really help boosting the fresh fruit with this enzyme. You can use it again like 2 to 3 weeks before bottling. all the way during aging and 2 to 3 weeks before bottling. We have samples, so please feel free to ask. The last point I wanted to talk about today was about mouthfeel. So using enzyme to improve mouthfeel is also something common. So in this case, you would use an enzyme that is called Vinotaste Pro. Vinotaste Pro is a purified enzyme that is a pectinase with beta-glucanase activity. Beta-glucanase activity is an activity that's going to cut glucans, so like the Enoflow Max we talked about before. This enzyme is going to help you break this chain of glucan. So you have a few things that to win from this. First, it's going to improve the settling and clarification, particularly if you are in a botrytis situation. You're going to improve filtration, yield and rate. But also, if you use it during aging, you're going to enhance the wine roundness and complexity. Why? Because, in fact, you start to break down the glucans from the cell walls of the yeast. So if you are aging on lees, you know, with time, there is a natural hydrolysis of the cell walls of the yeast. We call it autolysis, and it's just going to start to release compounds of the yeast, which are often manoprotein and some other polysaccharide, into the wine, and that's where you get the richness, the volume, the roundness, and the mouthfeel of lees aging. You can accelerate this by using an enzyme such as Vinotaste Pro that is going to basically accelerate the breakdown of this compound. So it's a very interesting tool if you have a shorter aging, but still you want to get this complexity and roundness of a longer aging. You can use Vinotaste Pro if you just want to increase a little bit your roundness. Very interesting tool in sparkling wine if you want to age your wine a little bit shorter, but still get the same mouthfeel. Vinotaste Pro is a great tool. You would use it during aging. Usually the time of contact is at a good month, 6 to 10 grams per hectoliters. And yeah, so you can see here an example of a trial that we tasted 4 months after the trial, after the addition of Vinotaste Pro. And basically we increased the sweetness, we increase the balance, we improve the length. The aromatic intensity didn't change, but the complexity overall increased. No more evolution or oxidation notes. We just have more fruity notes. This is just because the nose is cleaner, the wine is perceived bigger, rounder, more balanced, and so overall more appreciated. So as a take-home message, about enzyme, I hope you understood that enzymes can have many roles in winemaking, not only clarification. There is a lot of other roles and so activities with enzymes in winemaking and application. It's important to select the right enzyme for the right action because they are very specific activities for specific action and applications. So don't use an enzyme for clarification if you want to extract. Don't use an enzyme for just, you know, beta-glucanase if you want to extract. It's not going to work as you want, and you will have different results. One very important point is the purification. So we talked about it. If you want to make sure you don't have side effects and unwanted aromas, make sure the enzyme you use is purified. There is a lot of qualitative, practical, and economic advantage. With enzyme, you can increase your yield through extraction, but also compaction of the lees and your yield at filtration. So you actually improve your labor time. You also increase the quality of the wine by having a better extraction of aromatic compounds, of color, of polysaccharides, of higher quality juice. You can increase aromatic expression with enzyme that you can use during aging, and also you can improve the mouthfeel by giving roundness, volume, and weight. The applications of the enzyme, so each enzyme has its own application, but keep in mind that dosage, temperature, and contact time are all together. So if you ask me, how long should I put this enzyme on my wine? My first question is going to be, what's the temperature of your wine? And at which dosage do you want to use it? Or how long do you have? So we can adjust the dosage knowing the time you have and the temperature you have. So to conclude, if you want to do filtration clarification, we have Enzyme Clear. That's for clarification or flotation in juice, and Flow Max for really improving filtration clarification in wine. For extraction, any type of extraction from the grapes, Enzyme Crush. That's good for whites, that's good for rosés, that's good for reds. Many things to win, many advantage when you use an extraction enzyme. Aromatic expression, an enzyme thiol and an enzyme FW, an enzyme thiol to express more thiolic compounds, so more citrus, more freshness, fresh berries, and an enzyme FW if you want to push the terpenes, no rhizoprenoids, very commonly used on Pinot Noir, on Syrah, on Riesling. Then the last point would be the mouthfeel improvement that you can do, and this would be with our VinoTaste Pro, which is our beta-glucanase that really help to release quickly the manoprotein and other polysaccharide from the yeast during the lees aging. Thank you very much for your attention. I hope you enjoyed this